Okay, so if I want to solve for t, what would I do?
Well, it'd be 4 pi squared r.
4 pi squared, that's true. Okay, what could I do to both sides if I want to?
Divide by, or, yeah, half
I can. I could maybe cross multiply, I could flip both sides, I could cross multiply, because the g really just goes on top, right? So if I cross multiply, I'd get g times m sub e times t squared equals 4 pi squared r cubed. Agree? And then all I'd have to do now is divide each side through by gm and then square root it. And I've got an equation for orbital period then, right? So we get, what do we get? T squared equals 4 pi squared r cubed over g m sub e. I could square root both sides and get this, right? If I really wanted to be tricky, and that's fine, that equation works. In the book, it's going to be slightly different. What could I do with the 4 pi squared? Yeah, the square root of 4 is 2, right? So I could write that as 2 pi times the square root of r cubed over g m sub e, right? So I've got these equations, and they're in the textbook. You know, the textbook, I'll make sure, if I've already done it, I'll make sure that the textbook PDFs are right there by the assignments for each section. So you can just pull those up. That's fine, but just know how you could get them. So what about this one then? Let's go back to this problem. If we're trying to find, where was that? What did I do with it? Let's see. It was right there, right? So if we're trying to find the speed and they're giving us m and r, that's not a big deal, right? Because I can just use that equation right there, can I? What am I going to use for r? The radius of,
From the center of the Earth.
yeah, of the Earth, right? Because it's essentially going right at the, I mean, the problem is implying that he's going to throw that baseball, it's going to just kind of hug the surface of the Earth. Maybe it's got to go up 10, so add 10 meters. It can change your answer. No, right? 10 meters compared to 6 million isn't very much.
He's throwing it so fast, it's going through everything.
Yeah, he picked a really good place to throw it, so it's going to be, there's nothing very high, right? There's no mountains in the way. I don't know where he did this, but he picked a pretty good path, right?
So we don't have to worry about how high it is off the surface of the Earth. We can just take the radius.
And you get that, right? I mean, the implication is just that it's just scooting around the Earth, just above the surface. So all we'd have to do is pick the radius of the Earth. What if we were trying to put a satellite in orbit around the Earth at a height of 1,000 kilometers?
1,000 kilometers.
So that'd be, but I put it in meters, right? So I'd have 1,000,000 meters added to the radius of the Earth, right? And then that would be my r, okay? What's it going to do to the velocity? The further I get away from the center of the Earth, what does that do to the velocity in this equation?
Decreases.
Yeah, it goes down, doesn't it? It goes down. The further you are away, the slower you could throw the baseball, right? Or put the satellite. The slower the speed would be. Okay. All right. One more. Let's pick the challenge question. This is a great one. Oh, I love this. Okay, so the sun is considered to be a satellite of our Milky Way galaxy, right? It and all the other stars are revolving about the center of mass of the galaxy, which is at the center of the galaxy, right?
Wait. So there's the center of the galaxy and all these other universes are just
Well, no, this our galaxy, right? So the Milky Way galaxy is just a spiral galaxy, right? And
But
we're
is
just
that moving, or is it just some place?
no, it's moving. It's moving. So here, let's look at a picture. So you kind of put this in perspective a little bit.
5,000 years ago, there's a spike
Uh-huh.
spin to it.
Oh, you know that?
Yeah.
You're
It was exactly
just
that.
chose
Exactly.
Oh, don't bring that
Oh
up.
my God.
Don't do it.
Lincoln, everybody knows this, it was 5,000 years ago.
Okay.
And nothing has changed since then.
That would be blasphemy.
Yep.
Okay, let's see what we got here.
What do you have Peter Answers say?
You can see that? Oh yeah.
Wait, what is Peter Answers? Is that just the same thing? but different?
Yeah, that's what it's called.
I was used Peter Era. ISIS is hacking into us.
Okay, so here's our Milky Way galaxy, roughly, right? And so you can see, let me turn the light on here so you can see a little better. So here's where roughly the sun is, out here, kind of pretty far out, most of the galaxy, the vast, 99.99999% of it is closer than we are. And so all these stars are just rotating around the center of the galaxy, right? And so, yeah, we are in orbit about the center of our own galaxy.
So what's at the middle of the galaxy?
What's at the middle of the galaxy? Who can tell me? A huge black hole. Yeah, that is at the center of every galaxy. There's an enormous central black hole that sits at the center of all of them. Varies in size. Ours is, I don't know, it's on the order of millions of solar masses. The black hole. It's big, but there's some of them that are a lot bigger in other galaxies
So
too.
is our galaxy going around some other thing?
Our galaxy is. Our galaxy is a part of what's called the local group of galaxies, which is a part of a galaxy cluster. And they're all rotating about some other point, which is at the center of the cluster of galaxies. That's true.
So theoretically, in the future, once we can traverse our own galaxy and there's multiple different civilizations throughout the galaxy, will it still be?
Those are some
almost-
big ifs, but
I know,
okay,
I know.
okay,
Will
let's
it
just
still
suppose.
be
All right.
almost mythical to go beyond our own galaxy?
Will it be what?
Like almost mythical. Like for us to move within our own galaxy is like almost mythical isn't really the right word.
No, it is
Far
at
out
this
there.
point very far fetched.
Yeah.
Mhm.
Once we can do that, though, theoretically, would it still be very far fetched to move with? Like outside
Yes,
of our
it
own
would,
galaxy?
because the distances between galaxies are enormous. So yeah, assuming we are able to travel within the galaxy, traveling within the galaxy, realistically, the galaxy is, I don't know, anybody know how wide the galaxy is? No, it's a lot more than a couple of light
It's
years.
50,000 light years.
Is that what it tells you?
That's how many stars are in it.
There it is.
No.
Yeah, I think there's 100 billion stars.
Yeah, there's 50,000.
But 50,000 light years, the Milky Way galaxy. Okay, so that's roughly, it looks like that's about how wide it is. So think about that, Phil. 50,000 light years, that's a whole different level. We're talking about maybe going to like a nearby star or something, Alpha Proxima or Alpha Centauri. Then you're looking at 3 or 4 light years, right? Which would be phenomenal. To be able to make that trip would be ridiculous. At this point, it's just beyond the scope of any possibility. But to go across, come on, that's pretty unlikely. And then if you're talking about going between galaxies, you're talking about an order of just millions and millions and millions of light years. And so, yeah, that's pretty speculative.
Oh, it was not that hard a long time ago.
How's that?
Well, it was in a different galaxy, but
Far, far away.
it was.
Okay, that's
far,
what
far
I
away.
figured. Something like that was
Yeah.
coming. Had to be. Okay, so if we go back to our problem then that we're looking at. So if we go back to our problem, this is kind of interesting, right? So we should be able to do, these calculations aren't ridiculous. We know some things. We know what the mass of our sun is, and we can make measurements that allow us to pretty accurately predict how long it takes for us to go once around the galaxy, okay? So if the period of one revolution is this, 2.5 times 10 to the 8 years, that's long. It takes a long time to go around there, right? So we're looking at what, 250 million years to make one revolution around the galaxy? That's a long time, but it's a long distance too. We know the radius of our distance. We know our distance from the center of the galaxy is about 2.2 times 10 to the 20 meters, right? Huge, huge distances. But we ought to be able to then make an estimate as to what the mass of the Milky Way is, right? Does that make sense?
When you say mass of the Milky Way, you mean the black hole center?
I mean the mass of the whole galaxy, because we're orbiting around the center of mass of the whole galaxy, right?
When you say mass, is that like the mass of everything combined?
Everything combined.
So
right.
it's the space in between.
Or just everything closer to the center than us.
The space in between contributes very little to the mass, right? So it's going to be, but now think about this. When we orbit the Earth, right, if a satellite is orbiting the Earth, what is it orbiting? It's orbiting the conglomeration of all the matter in the planet is contributing gravitationally to that orbit, right? And if you eventually use calculus to look at this, what you find is that if you resolve where all that net force is coming from, right, the net effect of all that matter is at the center of mass of the system. So we treat it as the center of mass of the Earth, but it's not as though all the mass is actually there, right? The mass is spread out throughout the entire planet.
But we
Right.
treat it as if it all was there.
We treat it as if it all was there. Same thing with the galaxy. The matter is all spread out throughout the galaxy, but we're orbiting the part that is in, the center of mass of the galaxy, which is at the center of the galaxy. Okay, does that make sense? So this is not a phenomenally, it's not very difficult. I mean, the numbers are really big, and that's what makes it hard. But you should be able to use the equations we were just looking at. You can kind of reverse engineer those. You can solve for m in this case, right? The mass of the big M, the mass of the object that we're orbiting, and we can figure out what it is. And when we're done, we'll take a look at that. And I'm going to tell you right now that even though you do the math correctly, you're going to be off by an awful lot. You'll be off by an awful lot, and it won't be your fault. We'll talk about why that is later. Yeah. Exactly.
Would with the center of mass, would that still count everything that's out farther than us? Because that doesn't.
It's a good point, because it's like when we burrowed through the crust, the shell of matter outside of us didn't contribute to that. And it's true, although I'll tell you right now that there is a minimal amount of matter that's outside of us. And so you're right, what we're really calculating is the mass of the matter that's radially within our radius, right? That's going to account for well over 99% of the mass of the galaxy.
Aren't we on pretty close to the edge?
We're pretty close to the edge, and it gets pretty sparse as you get close to the
You
edge.
can almost say the outer rim.
Oh my gosh.
You could, if you were Star Wars, and that you could say that. Yes, sir.
So what is this question asking for?
So we want to know, we're trying to estimate what the mass of the galaxy is, and then use that to say, okay, well, we know what the mass of our sun is, so based on that, roughly how many stars the mass of our star are contained in the galaxy.
Okay, because it looks like it's looking for an adjective to finish the sentence.
It wants to know the mass of the Milky Way galaxy must be equivalent to the mass of how many, what number of stars like our sun.
Oh.
Yeah. Yeah, see what I'm saying? So maybe it turns out that it's, it should turn out to be, well, I'm not gonna tell you. You guys will figure it out. It's gonna be a big number, right? It's gonna be a really big number. But it's gonna be way off, and we'll get at why that is later. Okay. All right. Last thing I kind of want to show you, I never got a chance, being as it's a Monday. Tomorrow I'll give you a work day or tomorrow we're in the lab, and then you guys can use your interim period, to work on this stuff. I'll get Chromebooks. Last thing I want to kind of show you here is, no, well, maybe.
It's the basketball game.
Yeah, the basketball game.
Uh-huh.
Who won Friday, Sunday?
Oh, yeah, we should look at that, huh?
The team who won gets extra credit.
And then
Okay.
Shuma lost good.
extra credits.
Yeah, so much extra
Still
credit,
the same.
everything, and still getting it.
I like that idea.
I really like it.
Oh, wrong one.
As a prodigy.
As a prodigy.
I say my four.
No, you really gotta be like, you need to control your child.
By the way, but
Here it is.
I see what you did there.
Okay, here's some kind of cool stuff. This is what it would look like to go through a small wormhole.
How would they know?
Oh, you can calculate it. You can calculate it.
What it look like?
Calculate
Yeah.
how, John, you can calculate. Don't worry about it, John. Don't worry about it.
So what's a wormhole? A wormhole is just a wormhole is essentially like, to dumb it down in just a little bit. A wormhole is essentially like you're putting two small black holes at either end of a tunnel, and you're going to travel through you're going to travel through the rift that's created between these two openings. It's impossible to build. If we could build it, it would require some weird stuff like repulsive matter. It would require a mass of gravitationally repulsive matter, which we've never seen, but theoretically should exist. But it would require a mass of about equivalent to the mass of Jupiter of repulsive gravity to open up one throat of a wormhole that would allow a person to go through it. That would be that big. So it will never be engineered, but if it could be, look at what the warping of space looks like when you do it. This is really pretty cool. So as you go through this thing, look how space is going to be completely flattened out.
You would not what, River?
So what exactly do those colorful things do?
Well, that's sort of the structure of it's supposed to be the structure of the wormhole. And as you pop out the other side,
Someone who didn't want to deal with wormholes.
yeah, that's what you get.
That's weird.
Yeah, I got a couple others to show you. I'll put them on the site too.
Yeah. It's like, oh my god.
Just walked in, heard wormholes. Nope.
No, I didn't know there were still people here. I was like, what?
So,
What? Oh,
She's gonna be,
I gotta leave early again.
What's today?
Those are clarity
Oh, okay.
for the first time.
Yeah.
And then
Yeah, you guys are testing.
computer lab or Chromebooks?
Chromebooks. We'll go down. I'll get them.
I like the computer lab.
I'll see what they are.
All spring athletes, be sure to check the board to see if your practice has been canceled, delayed, relocated. At this time, we have boys and girls golf canceled. Every day I will post any changes next to the board across from the tennis. You're gonna have to check that late in the day, every day, to see any changes. Thank you.
just see the Google.
Looks like a hot roll.
Watch outside for that. Watch outside for that.
Right in the people.
Here. Okay.
Right. We actually turned the desks around and go down now. So.
Now look what you did.
We might be. I'll get one reserved just in case.
I thought that was impossible.